So it looks like this is actually working for the first time ever. Third time's the charm, I guess. It looks like there's 2 whole people. Sweet. Yeah. Let's see if this works. All right, regardless, it's just after 2. It looks like it's actually working for once, which is cool. If it continues to, awesome. Otherwise, somebody let me know it, like, stop. As I said, it looks like it's working. What we're gonna be talking about today is TIG welding for the 3rd time. Yeah, so first off, where to begin? Considering every time I've done this, it's failed miserably. So, TIG welding. If we go way back, I posted a video that I actually haven't seen how well or how bad it worked about the tools that you use when you're welding. And it's one of those things where you have your basic complement of hand tools and they're all derived from somewhere. And they've developed over the years. If you look at a hammer from 100 years ago, it looks conceptually the same, but materials and changes in construction and manufacturing methods, and then ultimately the materials that it's used on have changed significantly. So same thing with welding. You can trace everything back basically to blacksmithing. And blacksmithing, for those of you who aren't as familiar with that, is essentially heating metal in what we call a forge, and that forge allows us to reach temperatures that either allow for the metal to be moved more easily or even welded together. And welding is that fusing of materials, of metals at high heat. It depends, it's not where you change from a solid to a liquid necessarily, though you are butting up against that liquid level. Not necessarily like it would flow if left to its own accord, but you are at a point where it is fairly liquid. So as I said, if you trace it back, blacksmithing, forging, specifically would be called forge welding, where you take 2 pieces of metal and through coercion with a hammer and some type of, most likely some type of flux, which allows for oxygen. When you're talking especially about steel, is an enemy. You don't want it in there, you don't want it around it, because that will allow for a weak weld to occur or weak fusion. So we kind of can trace that from the forge to where we are in the modern day. There are tools that we still use, like this torch. Oops. And I actually have a welding tip on here. I think it's I don't remember what size it is off the top of my head, which is something I'll say frequently throughout this live stream, because many things aren't at the forefront of my mind, because I have not been teaching this as regularly as in the past. So I've got these sweet glasses, and this is a torch. So as I said, we start with a forge, which is an external heat source. We're using pressure and other things to fuse metal together. Well, this guy is one of our other big leaps forward, where we take a fuel source and an oxidizer source, and ironically we're introducing oxygen here, and by virtue of it burning, we're actually creating what we call an inert environment around the weld. That weld, excuse me, essentially, again, we want to keep oxygen away. Oddly enough, we are introducing oxygen through this torch. This is an oxyacetylene torch. Acetylene is our fuel. It is technically not a gas. It's actually, there's this weird situation with it because it's essentially dissolved in acetone, which is a universal organic solvent if you really want to get into the chemistry of it. But, so flip these down. These are actually darker than your normal set of sunglasses. And the reason for that is, you know, you don't want to go blind. So you can see here we have I have a flame. This is a pure acetylene flame. If I turn it down, you can see this is all carbon up in here. I don't know if you can see that with the resolution of the camera. I can see it just fine even with these darker glasses on. This pure acetylene flame, all it is basically burning. It's like a hydrocarbon flame, essentially. The same thing as if you burn gasoline, it's just much slower and controlled. You probably can't see me now. So, turn it up a little bit, start bringing our oxygen on. We go from pure acetylene to what we call a carburizing flame. That flame is mainly acetylene with a little bit of oxygen. And then we bring on a little bit more, and we get what we call an oxidizing flame. That oxidizing flame is what we actually use for welding. But, so we end up with a hotter flame. And that's kind of, so let me shut this down. That's the interesting thing is that, as I said, we start at the forge and we can trace forward to tools that we still use today. You're getting into a temperature where, I got a bunch of carbon floating around. It's like when you get hit in the face and you see all those little floaty things. So, yeah. You end up with, yeah, I didn't think that through. There's a lot. Okay, it's like spider webs, because you probably can't see them, but I can. So that's our fuel source. What we would do is we'd have a piece of metal such as this. We'd heat it up. The problem with that is consistency. We don't have necessarily a lot of control. It's a little bit harder to deal with. And the level of skill required, especially on thinner materials like this, right here, this piece of sheet metal, I believe this is 18 gauge, cold rolled steel. And the reason I differentiate that is because this doesn't have a scale on it, where, again, I don't know if you can see this, where hot rolled steel will have a scale built up. There's almost a protective layer. It's a little bit more complicated than that, but there's a layer that is on the steel. I actually ground this to prep it to weld on during today's demo. So if you look right here, you can see a buildup. There's some rust and whatnot, and then how I cleaned it with a grinder. And then we've got cold rolled steel, which is a process that doesn't give us that scale buildup. And when we don't have that scale buildup, like you can get hot rolled to a point where it's easily weldable, even with TIG. It doesn't take that long, but the point is this is a cleaner material right off. You will end up with either them rust eventually. So the process we're going to talk about today is called TIG welding. It's tungsten inert gas, not this gas. Both of these basically create or contribute to what could potentially be an explosion, which is great if we don't respect them. An inert gas is one of those gases, if you look at the periodic table, run down the right-hand side, last column, those gases are noble gases. TIG welding, which is what we're going to talk about shortly, originally it was called heliarc. That heliarc used a helium gas, and it was to, again, keep that oxygen out there, keep a really clean weld. And what we've seen as we've gone forward in time is we've moved on to an argon shielding gas. That argon shielding gas is, again, a gas that has no oxygen present in it, and it allows for what we call an inert environment to happen around where we're welding. Because as I said, so oxygen will actually get into a weld, and by virtue of it being present, it will cause what we call porosity, and it will cause a weak spot in that weld, which is not what you want, especially when you're relying on it to, keep gas in a gas tank for a motorcycle, or keep a frame together on a hot rod, or just in general, I hate going on rides at amusement parks because the welds are like, oh, look, that one's good, that one's less good. Probably shouldn't go on that roller coaster. But normally those are county fairs. No offense to anyone who works on that stuff. But there's a lot of times there's some shoddy welds that you'll find on stuff. Okay, so I talked about the lineage, started at the forge, started blacksmithing, throwing hammers, making metal hot. Then we move on through history, and this isn't like in the year 1722. This is kind of the overview. These are the big stops. We talked about torches, and that brings us to the modern day, and we touched on the heliarc, which is the direct relative to TIG welding, or tungsten inert gas. So this is the torch, and I've got my ground clamp hooked up to this table. So this entire table is grounded. So when I do a little bit of welding and a little bit later, I won't have to try to figure out how to clamp this. As I said, this whole table is grounded, and what we'll be able to do is just place this on here, it'll complete the circuit and allow me just to weld. I know I'm jumping ahead to a certain extent with some people's knowledge, but it's one of those things where this is kind of as I said, this took us 3 times to get to here. I want to show you something that's kind of cool, and if we have to go back, I can create other videos or live streams, etc. So tungsten inert gas, TIG welding. Talked about the gas. So that gas will come down through this torch, through this lead right here. There's a electrical lead, and then there's a gas lead, or hose tube, however you want to refer to it. It'll come down, the gas will come out here, and then it's directed by this nozzle. And I've got several different sizes here. I think these are 5, 6, and burnt off. So this was, I believe, a 7. No, it's a 6. So that's those 3. And again, I don't have like a great camera guy. It's just me out here. So these guys are generally made out of some type of ceramic material. They have a high temperature holdout. And then the tungsten side. This is a tungsten. Unlike steel, it has a very high temperature holdout or threshold. It's not going to melt quite as easily as a steel or aluminum, which most people are fairly familiar with. Everyone's probably seen an aluminum can succumb to heat in some way. And then we have the one thing about tungsten though is that it's very brittle. So it's strong in terms of holding out and also actually hitting it, but it's really brittle in terms of if I can break this tungsten right over this table and it be in 2 pieces, and whereas if I did that with a piece of steel, it would either bend or it would just look at me and be like, oh, that's great, you tried breaking me. So this is, as I said, this is the TIG torch, tungsten. We've got gas flowing through, tungsten inert gas. I'm actually going to turn this little valve on now, so when I forget to, so I don't get to later and make myself look really foolish. So the tungsten, I've got it sticking out a little bit too far right now. So this guy back here allows us to adjust it. And what I'll be doing is I'll actually be running a couple different beads on this metal. What I'm going to try to do is explain some stuff first, because it's going to get loud because my TIG welder's got a big old fan on it. And that fan is really annoying. So I'm going to get some protective equipment on here. My welding helmet is, I've got a buddy that makes fun of me for how old it is, which is funny because these didn't exist when a lot of people, like, this is what we call an auto dark helmet. There's an element in here. I can see, well, if I put a new shield in it, I can see clear, just like looking through a set of safety glasses or normal glasses. And then soon as there's a sensor in here, as soon as that sensor detects an arc, it will jump and basically turn this so that it's what we call level 10. And that's probably, these are a level 5. So, and your sunglasses, I think, are 2 or 3. So if you think, basically, I can't remember if it's exponential, but I think it's just a straight grade that 2 is twice as dark as 1, 3 is darker, so forth. So you really can't, when a level 10, you can't really see anything around you until the arc takes off, and then it illuminates it because it's so bright. As far as accuracy goes, whether or not this is truly accurate, it's like looking at the sun, essentially. These gloves probably should be replaced at some point. So I'm going to grab my jacket right here and try not to trip over the lead right there. You should always, as I said, we're looking at something that's about as bright as the sun, roughly. So one of the fun things that you can get when welding is a sunburn, and you don't want that because it hurts. I've done it many times, and I don't recommend it. I'm just going to throw, so basically right now, I've got something to cover my head so in case I get any sparks. It's not so much for this process, it's for some of the other processes where you get more sparks, but I'm just trying to show some good habits. So, helmet. I've had this thing about 15 years, and it still works. It's not the prettiest thing in the world. So what we're going to do, the first demo I'm going to do is show you what it looks like when I just strike an arc and run a bead without filler. And what is filler? Filler rod comes in a whole bunch of different varieties depending on what you're doing. So filler rod, this thing is our heat source. I need to generally reintroduce something because, like with anything, I'm putting two things together. So even if I push them really tight together, there's still going to be a gap. And I want to be able to fill that gap. So I've got a couple different things here. This is called silicon bronze. This stuff is technically not a weld. It's more of what we call a braze. It's a higher temperature, it's not a full fusion. You're using a dissimilar metal, which means not the same as steel, to basically stick them together, two pieces together. This one, I think, is our stainless steel. They're all stamped at the end. Oh, that's our aluminum. Yep, that's our aluminum. I just bent it at the end. If it was stainless, it would be like, no, I don't think we're going to bend. So that's some aluminum. If we were welding aluminum, obviously you use that. Each one of these materials is matched to a different alloy, and you don't have to have the exact same alloy. And in fact, sometimes you'll use different alloys to put different alloys together depending on the application. And then this is stainless steel. I think this is this is 308. Which is a class of stainless. And that brings me to this. This is a 304 stainless, and that number actually is talking about what that alloy is. Different numbers will say different things about it depending on first digit, second digit, last digit. such as tensile strength, the actual combination of alloys within it, and then also what it can be used for. So sanitary welding, and it's not sanitary as in like necessarily like the first thing when you talk about sanitary, you think of restrooms, or at least I do because of wastewater treatment and stuff like that. What it actually is sanitary piping in breweries and facilities that are making soft drinks and lemonade and anything where food will go through, and you want to have a really clean weld that doesn't allow for anything to be picked up along the way, because if something gets picked up, that ends up in the drink that you're going to drink or in your food, and it can be as simple as a little floaty or an off flavor, or it could be as bad as getting really sick. So this stuff basically allows us to reintroduce material to fill that gap. That's what filler metal is. That being said, you don't always need it. You can do what's called fusion welding, and I'll show you that. Actually, that'll be the second thing I'll show you how to show on this demo, will be how to just fuse these. I am not going to actually fully weld these together in the sense that there'll be a continuous weld through the entire thickness of the material. I'm just going to do a surface weld because I know at some point one of my former students who I taught to weld or contributed to their welding education is going to see this, and they're going to be like, well, he didn't full weld that. And I just try to be specific about what I'm doing. I'm just giving a demo. It's probably going to look pretty bad because I'm trying to talk and do stuff at the same time. You'll get different thoughts on this. I like my filler material to be smaller and manageable, because I normally am not welding stuff that needs to be perfect in terms of continuous welds. I normally am doing little parts because I have the convenience of going back to pressure testing stuff, looking at it, grinding welds out, which someone, if this gets larger view than 3 or 4 people, will be like, haha, yeah, you're a grinder, not a welder. That's some funny stuff right there. Okay, anyway. So, I'm going to turn the welder on right now. It's going to get really loud. I'll try to talk over it. I don't know if you're going to be able to see it. I'll be getting up and sitting back down as I do these between. So this is the welder right here that I'm using. It's a ESOB 252 Heliard. I've had this for about 16 or 17 years. We have different settings. The biggest setting on this is our amperage, and that's what we're using to measure our heat. So this machine, I choose an amperage, and that's what it stays at. These other machines, this one and this one are more similar. That one's a little bit different. I'm not overly worried about explaining it right now. Oh, the other thing is, I actually have what's called an accelerator pedal. It's below the level of the table, and that pedal allows me to control this. What I'm going to create is an arc. So, put down, and first things first, I got it turned up way too high. I don't know why I turned it up that high. Must have bumped it earlier. So, you can see how bright it gets. It probably actually flashes out the camera a little bit. So here we go again. little bit too much. I don't know if you'll be able to see this so much, this camera or the other one, but you can see the two little welds I did. One really cooking and the other one not so much. So let me turn that up just a little bit more. So that's what, when I teach people to weld, when we do TIG welding, we always start there. I don't know why it shows that weird amperage on those ends, but that's fine. So that's no filler. So basically the first thing you would do if you had a welder like this is you would do a bunch of those. No filler, time and time again, trying to make sure you're keeping your welds straight. And then what you would do is, the next thing I'd have you do is probably practice that with some filler material, and then you'd go back and forth with, between having filler material and trying to fuse stuff together. So here we go. Okay, so what I just did here, it's not a full weld all the way through. I had two pieces here. You can see them. I'm going to bend them that way just a little bit. I just tacked that together. When you tack something, what you're doing is you're putting a little tiny weld to hold it in place. You always want to try to weld from a tack to a tack, because when you introduce heat into a piece of metal, what's going to happen is it gets hot. When stuff gets hot, it expands. So if I welded from this to that end, from the tack end all the way down here, what would happen is as I moved, it would start trying to push apart. And then it would get all funky, and if I wanted this exactly to be a couple inches wide. So that's the other one. Now, as you can see, I've got two pieces. It's bending. Basically, I just broke it apart again. But I've got two pieces that are together. I don't want to jiggle it too much. So what I'm going to do now is I'm going to introduce some filler material. I do have to admit, my helmet's super dirty, so I can't see anything. So this is basically welding blind.
So what I'm doing, and I don't know if you can hear me right now, I'm introducing a little bit of that filler material.
I just popped my tack too. It's not super pretty. It wobbles a little bit. And as I said, I just popped my tack, which is a perfect example of how that's going to spread. And as I said, it's not super pretty because I've got my heat set a little weird. This is the first time I'm doing this on camera, so I normally am able to play with it a little bit more, but I'm trying to be somewhat quick. I'm not able to do like the normal cuts, like, oh look, super close up, or even be able to give you what it looks like behind the hood. So I did a little weld. It's not great, but it gives you an idea. You can see what we call a heat affected zone around the weld, and then this is on the back side, so I did get heat going all the way through. But if you look, I still have a consistent crack. That means I didn't fully penetrate through the metal, and that's what we're looking for. Is we're looking for a basically a consistent weld all the way through, so that we have what we call full fusion. Real quick, I'll show you. Okay. Use some of this silicon bronze. I was all over the place with that, but the bead itself looks done worse and I've done better. So, silicon bronze. Still doing the same thing. Yeah, I can still pick that up. Yeah, it's not super great. As I said, it's not super straight. I can't see a thing in that helmet. I should have thought that through. But see how it's a little bit different? It's not the same color. If I take my brush here, clean it up some, you can see how it's a distinct gold color compared to the weld I did before. That silicon bronze actually looks really cool in joints for stuff. You can use it for for certain things. There are people who use it structurally, not structurally like in a building, but for a structural piece on a, like, I see a lot of old school pedal bikers do it. It adds a really neat contrast. So that's a good chunk of what I got for today. That's TIG welding in a nutshell. Yeah, cool. So I guess that's it. TIG welding. Bye.